Section 10.2 is finding arc measurements. So, a couple of different things here, a couple of vocab type things. So, a central angle is when you have two radii that go from the center of the circle to the outside. I kind of think of it as a slice of a pizza. That is called a central angle in between those two radii. So, in that, we name that using the angle. So we can use ACB to represent this angle right here. So if the measure of ACB is less than 180 degrees, then the points on the circle lie on the interior and they form a minor arc. So this little red arc right here is a minor arc. So just a couple little quick things. A minor arc is less than 180 degrees. And then a major arc is the other piece of the circle, which is formed by the other, kind of the outside of that minor arc. So when we name that, so let's just summarize that, major is greater than 180 degrees. And when we name that, we use three letters to represent it. So we use this terminology here. So this is minor arc AB. So we would say this is AB, and then we have this little arc over top of it. So that's how we would name that one. A major arc, though, we usually use three letters to represent that. So we start with our starting letter, then we have another letter that goes through, and then we end at our ending point. So this major arc would be A, D, B, and we use that little arc above it. You can also do B, D, A, same type of thing. So the measure of an arc is the same as its measure of its angle. So we measure an arc in degrees. So if the central angle is 50 degrees, then that means the arc measure, which we represent using M and then the arc, is 50 degrees as well. So the major arc is just going to be anything that's over 180. So this one we just subtract from 360 because it's all the way around the circle. So 360 minus 50 is 310 degrees. So remember that the central angle is always the same as the arc measure. So it says find the measure of each arc of circle P. Also, I guess I forgot to mention it. That little circle with a dot in the middle says that that is a circle at center P. And then RT is a diameter. So remember, a diameter is going to split the circle in half. So the arc measure is always going to be 180. So let's see. RS is going to be 110. It's just going to be the same as the central angle. RTS is going to be R to T to S. So RTS, I'll do a little highlighting here so you can see what that is. RTS is going to be around the circle. Excuse my terrible tracing here. RTS is going to be that arc right there. So basically, it's everything besides the 110. So we can do 360 minus 110, and it's going to give us 250 degrees. And then RST is going to be, I'm going to use red for that one. RST is going to be this arc right here, and that is a semicircle, so that's going to be 180 degrees. It's going to be half of the circle. All right, the arc addition postulate, if you remember the segment addition postulate and angle addition postulate, those we're talking about smaller segment plus smaller segment equals the whole segment. Smaller angle plus smaller angle equals the whole angle. So this one is going to be smaller arc plus smaller arc equals the whole arc. So the measure of arc ABC is equal to the measure of AB plus the measure of BC. So those two added together are going to be that whole arc. So this says find the measure of each arc. Well, GE is just going to be GH and HE. So GH plus HE. So it's going to be both of those arcs added together. So GH is going to be 40 plus the 80 that we have for HE. So that is 120 degrees. GEF is going to be G to E to F. It's this whole entire thing. So it's going to be 40, 80, and 110 all added together. So that's 230 degrees. And then GF, we know is just going to be 360 minus that 230, which is going to be 130 degrees. All right, this one, we have a pie chart. They call it a circle graph, but it basically means the same thing. So they're giving us percentages from a survey. So the circle graph shows the results, find the indicated arc measure. So we want to find the arc measure of AC. Well, AC is going to be this and this added together. But we have to keep in mind that these are out of 100%, and 100% is not, we can't say that it's just 100 degrees because we know in a circle it's 360. So we're going to have to figure out the fraction of this, or the percent, and then multiply by 360. So these two together, it's going to be 30% plus 8%, and that's 38%. So we want 38%, which we say is 0.38 times 360 to get its arc measure. So 0.38 times 360 is 136.8 degrees. 136.8 degrees. Now ACD is going to be that plus the extra 23%. So 38 plus 23 is going to give us 61%. So 0.61 times 360 is going to give us 0.61 times 360, 219.6 degrees. All right, the next one says two circles are congruent if and only if a rigid motion or composition of rigid motion maps one circle onto the other. This statement is equivalent to the congruent circles theorem. So to be congruent circles, basically what it means is they have to have the same radius measure. So the radii have to be congruent to each other. So if this was 3 and this was 3, they would be congruent to each other. Two arcs are congruent if and only if they have the same measure and they are arcs of the same circle or congruent circles. So if we knew that in one circle this was 30 degrees, and then we have another one, this is also 30 degrees. Well, that doesn't necessarily mean that they're congruent arcs. Okay, we know that this is 30 degrees and this is 30 degrees. We know at least that they're similar to each other, but what we need to know is that the radius is congruent for both of these. Okay, because we can have circles that are similar, so the radius is different, but the arcs have to also have that same congruence. So looking at these theorems, two circles are congruent circles if and only if they have the same radius. So if they don't have the same radius, they're not congruent circles. And then this one says congruent central angle theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So we could say that this arc is congruent to this one if and only if, meaning we can also go the reverse direction, if those two angles are congruent to each other. So let's do a little application of that. Tell whether the indicated arcs are congruent, explain why or why not. Well, RS and TU, we have both of them being 90 degrees. So one of our arcs is this one right here. They have a central angle of 90 degrees. And then our other arc, this TU arc right here, also is 90 degrees. Well, just because they're the same arc measure does not mean that the arcs are congruent. And the reason for that is this one has a radius of a bigger radius, and then this one has a smaller radius. So they are not going to be, oops, not all real. They are not going to be congruent. So I'm going to put congruent and then cross it off. They're not congruent because the radii are not congruent. So the radii have to be congruent. They have to be the same circle. This one though, UV and WZ or YZ, these have the same radius and the same central angle. So UV is congruent to YZ, and the reason is because the radii are congruent. All right, and then the last similar circle theorems here. All circles are similar to each other. So similar, remember, means same shape but different size. And that makes sense. A circle has to be the same as a circle in terms of its shape, but the size could be different. So one could have a bigger radius and the other one might be smaller. Two arcs are similar arcs if and only if they have the same measure. So if we look up here, these arcs are similar but not congruent. They're similar because they have the same arc measure, but they don't have the same radius, so they're not going to be congruent to each other. And that is all.